So in this particular video, I want to go ahead and walk through an actual write-up of a hypothesis test, and we'll also be able to do a confidence interval with this one. So this says the union spokesperson claims that 75% of union members will support a strike if their basic demands are not met. A company spokesperson believes the true percentage is lower and runs a hypothesis test at the 10% significance level. What is the conclusion if 87 of the 125 union members say they will strike? What is the 90% confidence interval for the percentage of members who say they will strike? So when I do this, then I want to run a hypothesis test. And remember, when we run a hypothesis test, we're going to use the acronym PHATS. So P H A T and S. Remember, the P stands for the what we're talking about, the parameter. So P is your parameter. I want the true proportion of something. So I'm going to write it defined like this: P is equal to the true proportion. And we're talking about members striking. So the true proportion of members that will strike. And then your H stands for the actual hypothesis. And we always come up with a null, which we'll call H0, and an alternative, which we'll call HA. In this particular case, what we're going to do is we want to figure out what is the population parameter. What is the proportion for this? The population proportion, well, they claim, what is the initial claim being made? Well, they're claiming that it's 75%. So here your P is equal to 0.75. And then what I want to do next, I actually want to find p hat, because I want to use p hat as an estimator of what's going to happen next. So when I divide 87 by 125, I get a p hat of 0.696. And so because my p hat is lower, and they're asking me about, they believe the company spokesperson believes the true percentage is also lower, I know that this other p for the hypothesis to be tested is that p must be less than 0.75. So I'm gonna make my assumptions, and in my assumptions, here's what I have. I have a sample of, it looks like 125 people, and what we're gonna do here is, because they don't tell me if it's random or not, I'm going to assume these people do not know each other. And then the second thing I'm going to test is the success failure clause, the success failure. So remember, success failure says that success is n times p is greater than or equal to 10. Failure is n times q greater than or equal to 10. My n here is 125. My p here, the population parameter, is 0.75. If I multiply 125 times 0.75, I get 93.75. And that's greater than or equal to 10. My q, so 125 times my q here is 0.25. When I multiply 125 times 0.25, I get 31.25, which is also greater than or equal to 10. So the success failure condition is met. And the third condition I want to test, third condition is the independent condition, also known as the 10% rule. Remember, in the 10% rule, we always started off by saying, surely the sample size, which in this case is 125. So what we're going to say is that surely 125 people is less than 10% of all people who work for this company. So now what we have done is we've shown independence, or that the sample is independent of the population. And the next thing we're going to do now is we go to our T. Our T is the test. And we run this test through the calculator. And we're going to go menu 6, 7, 5. And we're going to do the one proportion. We have one single proportion here, and we're getting that from the one sample. This is a one proportion z-test. And I'm going to get all the information I have for this z-test from the calculator. And so when I go to my calculator and I type all this information, and remember they're going to ask me for what is the population proportion? The population proportion is 0.75. How many successes did I have in my population? Well, I had 87 members that are going to strike out of the total n, which is 125. And the last step is set the direction of the actual test. And remember, our direction is here. And so when we do all of that, we get this information here. So here are the values that I'm going to be looking at. And this is a run proportion z-test. And I'm interested in that z value. My z here is equal to negative 1.394. And remember, I need to write this probability statement. The probability statement says probability of the z statistic here, z, and I use the alternative next. And the alternative is less than z less than whatever that value is, negative 1.394, is going to be equal to this p-value right here, which in this case is 0.082. So the last step now that I have this is to test this at the significance level that I've given. And here my significance level, I'm running a hypothesis test at the 10% significance level. So to run this at the 10% significance level, what I'm going to do, I take that 0.082, the p-value, and I compare it to my alpha value. Well, that is going to be less than 0.10. When the alpha value is less than the p-value, we always reject the null. So we'll reject HO. We're rejecting HO, and HO is that the true proportion of members that will strike, because that's what your P is equal to 75%. We're rejecting that. So what are we really saying? Well, there is enough evidence here. We've rejected that because the sample that we've gathered gives us enough evidence to support HA. In this case, there is enough evidence to support, well, HA is that the true proportion of members that will strike is less than 75%. So based on this, if we're talking about doing this, they said that the only way they would do it is if they had a true percentage that was greater. They're not going to strike here.